Very good evening, students. Welcome to the class. How do you read? Nukul, Nandini.
Video 5 Victor Tango November Alpha November. How do you read?
Radio 5. Nandini, I can hear you 5.
Radio 5, Victor Tango November Kilo Charlie.
Roger, Nukul, Nandini, welcome to the class. It's been a while. Manan, welcome to the class. How do you read?
Radio 5, Victor Tango Michael for November.
Good. Students, check notes from your previous class. Just check what the last class. I think we were on lecture 48, gyroscopes. Is that right?
Affirm, sir.
Yes. So in gyroscope, go through the notes, see if you have any doubts. We had done wander. Basically, we had spoken about errors. Manan, did you go through that session?
Affirm, sir.
Nandini, how about you? Any confusions?
No, sir, I watched that lecture.
Good, good. Today we are going to wrap up gyros by making important notes about types of gyros. Okay. So there are 4 gyroscopic instruments that are of high importance to us in the cockpit. We are going to write important points about these. But students, for some reason, I am unable to start my video. Just a second, okay? Okay, fine. Just give me a minute, okay? Just stay. Just go through your previous notes. I'll give you a couple of minutes to revise. See if you have any doubts, okay? Let me see if I can fix this camera issue. Otherwise, we'll start without the camera. We'll focus on the notes. Okay, luckily the video is working. Thank you for waiting, students. Okay, do we have any doubts with respect to whatever error we have, types of wonder? Okay, students, I also wanted to talk about this thing that we are very close to finishing all your topics. So I think you should be prepared for your examinations. Maybe your computer number has come, maybe not come, maybe you have applied, you're still waiting. But I think it's about time that we started our final preparation. Okay. So I have certain ideas where I'm going to give you certain questions to solve chapter wise. Okay. So make sure your revision is thorough and make sure you simultaneously work along with the practice questions so that you don't have to do any final preparation before your examination. You're already prepared. We don't need that unnecessary burden because you have spent enough time behind navigation. So it's good for us. Okay. So we're not going to wait for the deadline of the examination to do everything again. All right. Okay, fine. So many students are now joining us. Some have the college and this, that. So everybody is watching recording. Okay. Just a reminder, where had we left? Types of gyros. There are two types of gyros.
Wonder.
As per the two types of gyros. Sorry, Nukul.
So we left wonder types of.
Yeah. I'm just showing the same. See, this is where we had left. It's been quite some time since we had our last lecture, students. I hope you are well revised, okay? The only problem that we could face is that due to not having recency of certain topics, maybe you studied a topic 1 month ago, 15 days ago, 45 days ago, chances are that you might get confused or you might forget things. Don't let that happen to you, okay? Or all our efforts that you have put since so long will go to waste. Other students of our batch have cleared. Okay. We also want to clear. So I want to be there. I want to be there with you till the time you clear. But after our lectures are over, hardly a few 4-5 classes are left, a few more topics. That is also extra that we are doing. So we won't have much of navigation. We'll be covering metrology and regulations. So you have to make sure that for you are focusing. Although a simultaneous Liu navigation batch is going on, if you want, you can anytime attend that batch also. Okay. So feel free to do that. But make sure we do not miss. We do not, get impacted because of the time and the free time and this and that between. So I think in order to keep you busy and keep you thorough, we should practice as many questions as we can. Okay. So from types of gyros, we saw displacement gyro, rate gyro, students. Now remember, it's a completely different topic. Manan, are you following? Manan and Nandini?
Confirm, sir.
Just a refresher because it's been quite some time and we are continuing. So one will give you pitch angle up and down, displacement gyros, and rate gyros will tell you turn in the horizontal plane. Rate of change of angles. And which angles? Directions are angles, right? 0 to 360. Measures angular rate gyros, that is rate of change of angles on the right. On the left, displacement gyros, they measure angles, not the rate of change of angles, but only angles. So there are two types of gyros. One will check the displacement or the angular difference. The other will check the rate, which is the angular rate. Okay. So the angular rate, as we had written down, rate 1 turn, rate 2 turn, the instrument that we use for rate gyros is known as turn and slip indicator or rate of turn indicator. Okay. And in displacement gyros, we have a gyro which can measure pitch angle. We have a gyro which can measure bank angle. So pitch angle will be measured by a gyro known as artificial horizon. On and bank angle will be a part of your turn and slip indicator only. So which gyro will give me rate of change of angle or measure of angular turn? Possibly there is just turn indicator, but we will have a DGI, directional gyro indicator, which is just like a magnetic compass, which we will be getting with respect to this change in heading option. Then we saw what kind of gimbal system is used. Gimbal system is used in this and that. Okay. Examples also. Then displacement gyros are divided into two gyros, space and tide. Then their description. What is wander? Wander is drift and topple. Real and apparent, wander, real and apparent wander. Okay. So it is tricky. You need a fresh state of mind to study gyros. But when you are into gyros, I hope that you're not facing any confusions over here. So today we are going to wrap up with our gyro. It's very easy. I'm just going to give you important points about these different types of gyros. So write down types of gyros and their classification. Okay. Now we are going to start with, so there are actually four gyros: DGI, artificial horizon, turn and slip indicator. This turn and slip indicator is also known as rate of turn indicator. And last, turn coordinator. Okay. So these are your four gyros. Okay. Now we'll start with number one, DGI. DGI is directional gyro indicator. Okay. It will show you your headings. Okay. A magnetic compass will also show you your magnetic headings, but it has certain errors, turning errors and acceleration errors. DGI, when aligned with the magnetic compass, will give you correct headings without those errors. So the DGI is better. Okay. So most of the aircrafts, sophisticated aircrafts will have DGI instead of a gyro, instead of a compass. Compass will be there as a standby equipment also, and as something on which the directional gyro is indicated. Where will the directional gyro get the magnetic references from? They will get from the compass only, but it's just that they are free from the errors. Okay. So point number one for DGI. What is the type? Directional gyro indicator is a horizontal axis tied gyro. Okay. Horizontal axis tied gyro. Now, ideally, I wanted to give you these notes in a tabular format so that you can compare all the four instruments together. But we'll keep that in the assignment. I'll ask you to make a table later on. Okay. So we'll write notes individually. Later on, the section columns that I have made 4 columns. Similarly, you can make table in the assignment that I'll give you. So directional gyro is a horizontal axis tied gyro. Okay. What is the purpose? Purpose of directional gyro? Directional gyro provides datum. Okay. from which heading can be measured. Simple. It is used for heading measurement, but the definition says the purpose of DGI is to get a datum from which heading can be measured. So the gyro gives us a datum, and any deviation from that datum is actually seen on the instrument as a proper heading of the aircraft. Okay. Write down point number 3. Spin axis. Okay. If we have to figure out what is the spin axis of the DGI, so the spinning takes place in the yawing plane. Okay. These are keywords, and remember these words as it is. It's a very short way to learn important points about these gyroscopic instruments. So the DGI has a spin axis in the yawing plane. Okay. Number 4. Freedom of movement. Can the gyro move in all 3 planes, in 2 planes, or only in 1 plane? So directional gyro has a freedom of movement in all 3 planes. Okay. What are the limits? When the aircraft is pitching, the gyro gives you limit up to 85 degrees accurate readings. It means the gyro doesn't topple up to 85 degree. Okay. And during roll, also the gyro gives you 85 degrees. Okay. Now, how do we move the rotor of a gyro? Gyro is all about a rotor moving at a high RPM, right? So either air-driven gyros are there, driven in circular formats through air pressure, or we have electrical gyros using DC motors or AC motors. Obviously, DC motors or torque motors are used. Okay. So talking about that, what is the rotor drive? Okay. Rotor drive, we use jets of air jets in air-driven DGI. Okay. And we use torque motors, special type of motors with a torque force. Okay. Torque motors in electrical driven gyros. Okay. Very simple. I would suggest you all read Oxford text once after our sessions are over on gyroscopes. After our sessions, if you read through Oxford, you will easily understand everything that it is important for you to understand. Rest other things which are not important, you can simply skip. Last, errors. Gimbaling error. Types of errors. So DGI has random random wander, and apparent wander. And then we have rotor speed error. And we also have transport wander. So all these errors are applicable to DGI. So these are 7 points about DGI. A DGI can be vertical card or a horizontal card reader, just like a compass. If you remember from your memories the diagram, if not, you can check it in the textbook when you give the textbook a read. DGI. It's a horizontal axis tight gyro, which has freedom of movement in all three planes. The spin axis is in the yawing plane. Okay. Purpose is to provide a datum for the measurement of heading. Okay. Limits are 85 degrees pitch and roll. Sometimes people think that pitch and roll are only associated with artificial horizon. Yeah, but when a gyro has all 3 degrees movement freedom in all three planes, it will also move in pitch, it will also move in roll. So there it has certain limitations. Okay. Rotor drive and all errors included. Okay. Write down the second one. Manan, what is the shortcut about? Tell me.
Yeah, so gravate 2. It may,
Where did you get the reference from?
so randomly I was seeing a video on YouTube about DGI. For there I got it's THARP. THARP, T stands for tight gyro. HA means horizontal axis gyro. R for rigidity and P for precision. And 2 stands for 2 degree of freedom. And for error, it's gravate, GRAVT, gravate. It's gimbal error. Then, as we see, gimbal error, random wander, apparent wander, transport wander. That's.
Okay, okay. Let's write down about artificial horizon. It has 3 planes of freedom. Okay. 2 degree and 3 degree. You are saying 2 degree of freedom. Here we have not mentioned that. We have mentioned 3 degrees, 3 planes of freedom, freedom of movement in all 3 planes. Remember, that's the difference from your shortcut that we have. Okay. Let's write down artificial horizon. Artificial horizon. Now, this is that instrument where you see sky and earth and aircraft in between the two. Okay. What is the type for artificial horizon? Okay. It is a vertical axis earth gyro. Artificial horizon is a vertical axis earth gyro. At first, what is more confusing is the type of axis. So that's why we are making it much more clear. Vertical axis earth gyro. So the axis of the gyro is like this, vertical. The rotor is horizontal. Okay, write down purpose. To provide information of aircraft's pitch, attitude, and aircraft's roll attitude. It will help me check whether my aircraft's pitch and my aircraft's roll both are in the same, both are within the safe limits or not. Write down number 3. Spin axis of artificial horizon. It is vertical by Earth's gravity. A gyro, the name itself says the axis is maintained by the Earth's gravity. Vertical axis, already written down. Okay. Spin axis. Right, number 4, limits. In limits, pitch I get 85 degrees and roll I get complete. Remember, okay? This could be a point of confusion between all the different ones. So DGI and AH pitch is 85 degrees limit. Roll is 85 in DGI and AH is complete. We get complete roll. So roll is not an issue. Rotor plane. Okay, it's not rotor drive, it's rotor plane. Rotor plane is horizontal, right? Rotor is horizontal. And rotor plane provides a stable lateral and stable longitudinal references. Yeah, freedom of movement we are not writing for AH. Okay. So we have written down purpose, we have written down the axis, we have written down the rotor plane is horizontal and it provides stable reference for longitudinal and lateral references. Spin axis is vertical by Earth's gravity. Limits, pitch limit is 85 degrees and roll is complete. One more point we'll add here. Now AH can also be air driven or electrical. Okay. In electrical artificial horizon, vertical is maintained by 2 mercury level switches and 2 torque motors. Just remember this much, okay? In a normal gyro, the vertical is maintained by Earth's gravity, but when the gyro in AH is electrical, the vertical axis is maintained by 2 mercury level switches and 2 torque motors. Okay, this is just some theory. So freedom of movement, okay, degrees and plane. Keep your mind open if you come across any such references in your textbook where it is plane or is it degree of freedom, either plane of freedom or degree of freedom. The same, you add a note in your notebook when you go through it, okay? And you bring it to my attention also. Now, extra emphasis has to be put on number 3. Turn and slip indicator, also known as rate of turn indicator. Now, this particular gyroscopic system has 2 functions. First, to give me my rate of turn, the angular rate of turn, and the second is to show my slip, whether my turn is correct or turn is slipping in or slipping out. If you remember skidding in and slipping out diagrams, students, diagrams were shown to you. Do you have any memory, Nukul, Nandini, Manan? There is a ball, small ball in a glass tube. Yeah. Okay. So in this instrument, we divide it into 2 parts. Okay. The first part is rate and turn indicator, and the second part is slip indicator. Okay. So the small glass tube will show whether your turn is perfect or not, while the measurement needle or the aircraft symbol with the degrees will show you what is the degree value of that particular turn. 3 degree, 5 degree, 10 degree, 15 degree, and so on. Okay. So rate and turn indicator, point number 1, type. Okay. It is a rate gyro. Now slip indicator is not a gyro, students. Okay. Slip indicator is, if I have to write type, then I'll say my slip indicator is a pendulous device. Okay. Purpose of your rate and turn indicator: measures rate of turn about vertical axis. Measures rate of turn about vertical axis. Remember, about vertical axis, not horizontal axis. Okay. In type, you add horizontal axis rate gyro. In type, add horizontal axis rate gyro. The turns are about the vertical axis. So here you should not get confused, thinking, sir, why we have 2 different types of axes. Okay. The purpose of slip indicator, on the other hand, is shows balanced turn balanced bank angle and shows amount of slip or skid. All these indications are given to you by just that one small curved glass tube with a small ball inside it. All three things are indicated by the same. If it's in the center, it's a balanced turn. If it is in the center, it's a balanced bank angle. If it's in the center, there is no slip or no skid. Point number 3. How many gimbals or gimbals? We have one gimbal in turn indicator, only one gimbal. Here, we don't have to add gimbals because it's not a gyro rotor in your slip indicator. Okay. So you will write number 3 uses ball in tube inclinometer. So it is known as inclinometer, the tube in the glass in which there is a ball, just like a spirit level to measure parallel, uses ball in tube inclinometer. Okay. Degree of freedom for turn and slip indicator. One gimbal, 1 degree of freedom. Okay. Turns. Very important, although not very important for CPL. Still, you should learn it. Rate 1 turn. In rate 1 turn, you cross 3 degrees every second. Okay. And then there is a rate 2 turn. In rate 2 turn, you cross 6 degrees every second. These are the 2 turns at which you have to initiate your turns, 2 rates. Okay, standard rates turns, that is standard turn rates. So the pilot has to turn, if the pilot has to make a 90-degree turn, 3 degrees in 1 second, 3 threes are 9, 90 degrees in 30 seconds. So the pilot has to complete a 90-degree turn in 30 seconds. So a 180-degree turn will be completed in 1 minute, 60 seconds. While in a rate 2 turn, 6 degrees, 6 6 are 36. 1 minute, you will complete a 360-degree turn. So rate 1 turn, 3 degrees, you will write 1 minute, you cover 180 degrees. And here, 1 minute, you cover 360 degrees, like this. Okay. So rate 1 turn, in 1 minute, you will cross 60 degrees. Correction, 180 degrees. 6 threes are 18. And rate 2 turn, in 1 minute, you will cross 360 degrees. You'll complete a 360-degree circle or 180-degree circle. Your holding patterns generally are rate 1 turns only, 3 degrees per second. Okay. So why do we call it rate 1 and rate 2, students? Rate 1 will mean that you will complete 180 degree in 1 minute. Okay. And rate 2 says that you will complete two 180 degrees in 1 minute. Okay, if you're ever thinking why rate 1 and rate 2. So rate 1 says in 1 minute, 180 degree. Rate 2 says in 1 minute, double of 180. That is 360 degrees. So if you're following a rate 1 turn to complete a 360 degree turn, how much time will you take? You will take 2 minutes. If you're following a rate 2 turn to complete a 360 degree turn, you will take only 1 minute. Okay, remember this. Write one more point, rotor speed. Now this is one gyro where you don't need high rotor speed, okay? Why? Write down. Lower rotor speed than other gyros because high rigidity is not required. So turn and slip indicator does not require high rigidity compared to others. So the rotor can be a slow RPM rotor also. Okay. Let's write down a couple of more points about the slip indicator. Whenever your bank angle is too high, students, why bank angle? In order to turn, you have to bank, okay? Your aircrafts are designed in such a way that you cannot just turn like this. In order to turn right, you have to first bank and then turn. In order to turn left, you have to bank and then turn left. You cannot just simply turn like this, okay? You cannot do that in an aircraft. You cannot do it beyond certain limits. It's not safe also for the aircraft structure. So when you have too high bank angle, when your bank angle is too high, you get slipping in. Okay. And when you get too low bank angle, so when your bank angle is too high, then you are slipping in. When your bank angle is too low, you are skidding out. Remember. Too high bank angle, slipping in. Too low bank angle, skidding out. Slipping in, the ball will come inside the turn. Skidding out, the ball will go outside the turn, like that. So for the pilot, it becomes very easy to manage the turn. The pilot has to make sure the ball is in the center of the inclinometer by adjusting your turn. Okay. Manan, see if you can find out degree of freedom for DGI also, because you are saying 2 degree of freedom and I've given 3 planes of freedom. So I think the statements are a little contradictory. Nukul and Nandini, you also try to find out when you're doing self-study or reading degrees of freedom, okay? And whenever you're learning from YouTube videos, make sure you know the reference from where they're teaching, because there are many aviation videos, but not all are accurate to our CPL studies. Okay. Of course, the knowledge is universal, everything is same, but still there are certain differences. So we have to make sure that, you know, we are not learning anything extra or anything wrong that is not relevant. So when you're watching videos, half of the things you have to learn to let go also. You don't have to learn everything from such videos. Okay. Go through the points, see if you want to add something, students. Okay, who can tell me? Rate 1 turn completes in dash. Option A, 1 minute. Option B, 2 minutes. Option C, 3 minutes. When I say complete, it means a 360-degree complete circle. Okay. Rate 1 turn completes in 1 minute, 2 minute, 3 minute. A, B, C. Manan is saying B. Nukul, Nandini?
2 minutes.
2 minutes. Very good. Nandini, rate 1 turn.
2 minutes, sir.
2 minutes to complete 1 circle. Yeah. Great. Last one is very easy. Turn coordinator. This turn coordinator, students, is a development of the turn and bank indicator only. Okay. So either you will see a turn and slip indicator in the cockpit, or you'll see a turn coordinator. Most of the times these days is the advanced one only, turn coordinator only. It is as same as showing you the bank also and showing you the slip indication also. Okay. So we'll write in simple points. It is a development of turn and bank indicator. Okay. Turn coordinator, second point write down, shows turn through bank and balanced turn. In bracket, you will write slip or skid. Same function. The functions are not going to change. There's hardly any difference. Type, it is a rate gyro. Definitely, it will not change. In this rate gyro, axis is 30 degrees to the aircraft longitudinal axis. So the gyro axis is 30 degrees to the aircraft longitudinal axis. Remember, this is the advanced version. Okay, remember the numbers. Why? To make the aircraft sensitive to banking and turning. So this is an added point for turn coordinator. Do not confuse it with turn and slip indicator. The rotor axis, the gyro axis is at 30 degrees to the aircraft longitudinal axis to make the aircraft sensitive to banking and turning. Okay. Remember, please, students. How many gimbals? It has a single gimbal. Turn coordinator has a single gimbal ring pivoted longitudinally in the case. Sometimes questions will be very confusing. They will say mark the correct statement for turn coordinator, and they will give you three statements. It has multiple gimbal rings pivoted laterally. It has single gimbal ring pivoted longitudinally. It has single gimbal ring pivoted longitudinally, laterally. A, B, C. So one point can also come into questions. These are such points, such important points that can come into questions. Okay. So you have to very thoroughly understand your gyros with respect to this point of view. Then when you read the textbook, whatever is resembling with what we have learned, focus on that only, and anything extra that is of relevance, degrees of freedom or this or that, you can add those extra points here. Our notes are also inspired from Oxford only, but you can add more notes in your notebook. Okay. So I'll suggest before your next class, you do a thorough revision of Oxford gyros. Just read. You don't have to learn everything in depth. Okay. Any questions, students? Manan, how was your championship? I hope you're free now from next week onwards to attend lectures, because we'll be doing other topics also, other subjects.
Perform, sir.
Good. Did you all win?
No, sir, it was league, so
Did
we
you all
want
qualify?
no, we want qualify.
Okay, hard luck.
Yes.
How many gimbals and degrees of freedom does a DI, directional indicator, the DGI, have? 2 gimbals, therefore 2 degrees of freedom. Okay. It has 3 planes of freedom. Make sure you don't change that. Did we write gimbals here? No, we didn't write how many gimbals it has, right? Good. So you have a couple of points to add in these notes when you're reading. How many gimbals in the DGI and what is the degree of freedom? That's it. What is this application, Manan? The picture that you have sent, is it random or have you got it from someone?
No, sir, it's random.
Fine. Any further reading that you do, students, please run it by me. Fine, you can do further reading from here also, but make sure you also do further reading from the text as I'm asking you to do. Now I'm going to teach you 2 new things. They are little complicated, but we will solve them just in case. I don't think they will be coming in your CPL examinations, but nevertheless, it's important to learn in your entire course of your flying studies. Okay. So even if you don't do this, I've seen students pass, but I want you all to do it just in case the question is difficult or the examination is difficult. Okay. So what is it? Yeah. Nandini is just away from the session. Okay. I hope you all remember the formula for rigidity and formula for precession. Okay. I'm just checking with Nandini what happened. Nukul, what's the formula for rigidity? Manan, what's the formula for precession?
So for rigidity, moment of inertia into RP, rotor RP.
And moment of inertia is depending upon?
mass of that disk and size of the disk, rotor disk,
Rotor diameter, right?
rotor diameter. Yes.
Manan, precession.
Torque by rigidity.
Precession. Give me the formula.
Sir, it's torque by rigidity.
Torque by rigidity. Okay. And what is by rigidity? What is the formula for rigidity?
Moment of inertia and rotor speed, IR.
Moment of inertia. IR. Manan, explain correctly, please. You can check your notes.
Are you asking for the definition of rigidity?
Formula for rigidity, Manan.
Or
Yeah, Manan. Formula for rigidity.
it's moment of inertia to RPM, RPM of rotor.
And formula for moment of inertia.
Formula for moment of inertia is mass and radius of rotor.
Yes, very good. Okay. Nandini, can you hear me well?
Yes, sir, I can.
Okay. There are two types of numericals that we are going to solve. Try to focus, okay? Not this will be very handy. And if you don't understand, please ask. Okay, it's very simple, and there are specific steps to solve these. There is no logic, nothing. You have to just remember the steps to solve this. Number one, to calculate correct bank angle for any given task. Example question: for a task of 360 knots, find correct bank angle. So how to determine what is the correct bank angle? It all depends upon your task. Okay. Whatever your task is, your bank angle will change. The optimum bank angle or the correct bank angle for you. Okay. So question number 4, for a task of 360 knots, find the correct bank angle. Okay. Solution. Write down the steps in solution. Step 1, find 1/10 of task. So 360 divided by 10 will give me 36. Okay. This is step 1. Step 2, add 7 to above answer. So 36 plus 7 is equal to 43. Step 3, result is accurate bank angle in degrees. So the answer is 43 degrees. This is the accurate bank angle for a task of is correct bank angle for a TAS of 360 knots. Easy, right? Just find out 1/10 of the TAS and that then add 7 to it. Okay. Question number 2. Find bank angle for TAS 250 knots. Solution: 250 upon 10 is equal to 25 plus 7 is equal to 32 degrees. Got it, everyone? How to find out the correct bank angle for a particular TAS? Yes, no, Manan, Nukul, Nandini?
Yes, sir.
Easy?
Yes, sir.
You'll
Yes, sir.
remember? Find out 1/10 of the TAS and add 7 to it. That's it. Answer you will get in degrees.
Sir, you could please a little bit scroll up. Okay, sir.
Write down one more. Find out the correct bank angle for 315 degrees. TAS. Put your answers in the chat box. (31.5 plus 7 is equal to 38.5 degrees. Correct. Nandini, well done. Nukul and Manan, what are your answers? 38.5 degrees, correct? Nukul?
Same, sir. 38.5.
Very good. Now the second type of sum. To find out the radius or diameter of a rate 1 turn. Now this will take you back to geometry. Okay. Note. Okay. Center is C and this point is A. Okay. So CA is equal to radius of a circle. Okay. And if this is line B to A, then BA is equal to diameter. And diameter is 2CA. That is 2R. Radius R. Okay, diameter. And the whole circumference, okay, from Bravo to Alpha and then Bravo again. The total length is the circumference. Circumference formula is pi d. Okay. This is the formula for circumference. Or 2 pi r. Okay. Pi value is 22 upon 7. Remember this. Use fractions or 3.14. So this is the formula for circumference. 2 pi d or diameter is actually 2r. Simple as that. Okay. So this is a formula. This is the radius. This is the diameter. You need to know all these things about circle. Circumference is the length of the entire boundary of the circle. Okay.
Okay.
Okay. Question. Your TAS is 360 knots. Okay. Rate 1 turn. Find radius of the turn. This is the question. In the examination, the question might have a couple of more information also, a couple of more details, but you don't need all those details to solve this. Okay. Now rate 1 turn takes 2 minutes to finish 1 turn, 1 circle. Okay. So solution, step 1, rate 1 turn takes 2 minutes to complete a circle. Remember this, 2 minutes. Okay. Step 2, TAS is 360 knots. It means 360 nautical miles. Okay. In 1 hour. Okay. Therefore, in 1 minute, how much will I travel in 1 minute? If in 1 hour I'm traveling 360 nautical miles, then how much am I traveling in 1 minute? In 1 minute, 360 divided by 60
Divided by 60.
is equal to 6 nautical miles. What does it mean? It means that on this circle, if I'm having a rate 1 turn, then at 360 nautical knots, I'm going to travel a circumference of 360 degrees. Okay, or 360 nautical miles in 1 hour. So in 1 minute, how much am I traveling? In 1 minute, I'm only
6.
traveling 6 nautical miles. Let's say 6 nautical miles in 1 minute. But a rate 1 turn takes 2 minutes to complete 1 turn, right? So you got step 3. You get from step 1, rate 1 turn completes in 2 minutes. Therefore, if 6 nautical miles is traveled in 1 minute, then 12 nautical miles are in 2 minutes. So how have we have exchanged the values by first converting my speed into nautical miles. If it would have been 500 nautical miles, I would have got 500 nautical mile, 500 knots. I would have got 500 nautical miles in 1 hour. So in 1 minute, I would have deducted 500 by 60, and in 1 minute, I would have got certain nautical miles. Because a rate one turn takes 2 minutes to complete, so I'll double the value traveled in 1 minute by 2 minutes. Okay. Therefore, 12 nautical miles is the circumference, okay, for 1 degree turn. If in 2 minutes I'm traveling 12 nautical miles at this speed, it means the circumference of that particular circle will only be 12 nautical miles. Because I'm completing a 360-degree turn in 2 minutes. So I'm only having a small turn. In a small vicinity of 12 nautical miles, I'll be completing my turn. Step 4, use the formula. Circumference is equal to pi d. Therefore, 12 is equal to 22 upon 7 into d. So you keep d here. So 12 into 17 upon 22 becomes your d. Is everyone following? Nandini, Manan, Nukul, are you following? How? Very simple, but we have to remember the steps. 12 into 7 by 22, use a scientific calci. Is equal to 3.1 nautical miles. This you can round it off to 4 nautical miles is your diameter. Therefore, diameter is equal to 4 nautical miles and radius is equal to diameter by 2. Remember, okay, is equal to 4 by 2 is equal to 2 nautical miles. Students, you are one of those few people who have the luxury to study in detail at peace before your examinations, because you are done with your training, you have done good job with your performances. Okay, you just have to make sure all that you have studied you don't forget and be prepared. So within 15 days to 20 days, be prepared for navigation exam by yourself. Okay. Add this formula in this list of circle. Radius is equal to diameter by 2 also. Add that also. So the logic is circumference is the area completed in one circle, and rate to turn will take 2 minutes to complete one circle. So if I can figure out how much distance is my aircraft traveling in 1 minute, then in 2 minutes I'll get the circumference, and using that circumference I can figure out the radius and diameter. Nukul, will you remember? Manan, will you remember this? Nandini, where did you miss step 3? Nandini, see if you know the solution.
No, sir, I wrote step 3.
Step 2?
I wrote step 3, sir.
What about step 3?
I wrote step 3.
3. Okay, good. Did you get the answer? So step 3, we know that one 360 turn is completed in 2 minutes.
2 minutes.
And as per the speed in 2 minutes, we are traveling 12 nautical miles. So the circumference for your turn would be 12 nautical miles. Because one 360-degree turn will give me one circumference. Nandini, so step 4, circumference is pi d. Circumference is 12 nautical miles. Pi is 22/7. Diameter is something that we need to find out. And radius. So I keep diameter here 7/12. 7 into 12/22. I get 3 points rounded off to 4 nautical miles. That is a diameter. And your radius is half of diameter. Always. We have added that 1 point to the formula here.
2 by
Radius is equal to, yeah,
D dash.
diameter by 2. Nandini, see if you're getting the answer. Do one more sum, everyone.
Sir,
As-
can you show step 4?
Step 4 is just, we know 12 nautical miles is the circumference for rate 1 ton. And the formula for circumference is pi d. That's it, Nandini. Are you following, Nandini?
Yes, sir, I understood, but I just wanted to write. That's all.
Yeah. You understood, right? That's more important.
Yes, sir.
So radius is half of diameter. You got your diameter, you got your radius. I'm giving you next sum. That's 410 knots. Find radius of rate 1 ton. Let's see if you can solve it. I know step 1, I will take 2 minutes to complete a circle. Step 2, how much in 2 minutes am I traveling? 41 knots, 410 knots, at 410 knots. So 410. So 410 divided by 60. 6.83 nautical miles I will travel in 1 minute. So in 2 minutes, I'll travel 13.6. So 13.6 into 7 divided by 2. Divided by 22. Okay, submit your answers, okay? 410 divided by 60, 6.83 into 2, 13.66 into 7 divided by 2, 22. Okay. Manan, what's the diameter?
4.45.
4.45. Are you using scientific calci to do it? Yeah, use calci only, okay? Step 1, I know 2 degrees, 2 minutes, time taken 2 minutes. Okay, Nandini, your answer is accurate to mine. Manan, your answer is not accurate to mine.
Yeah, because I have taken 7 instead of 6.83.
Okay, let's see. 410 by 60 gives me 6.83 nautical miles in 1 minute. Therefore, so you're taking it as 7, right? That's what you're saying.
Yeah, it's
So you
7.
rounded it
So,
off to 7
7.
nautical miles.
Yeah, so 14
in 1
in
minute.
2 minutes.
Okay, therefore, into 2, therefore, 13.66 nautical miles in 2 minutes. Or you have got it as 14, right? Like this. So this 14 is your circumference. Therefore, circumference is equal to 13.66 or 14. We'll do both. 13.66 is equal to 22 upon 7 into diameter. You can write down. Okay. Or we can do it as 14 is equal to 22 upon 7 into diameter. So here I get is equal to 4.34 nautical miles is the diameter. And here diameter is equal to
Yes,
4.45. So Manan, there is a thin line between when to round it off and not to round it off. So your answers, if they are rounded off, you can accept them. Otherwise, you stick to your uh, accurate answers while you're solving through the navigation, through the calci. But the answer is very close anyway. It's okay. But half of the times, if the rounding off is not done, then we will also not do the rounding off. It's like that. Therefore, radius is equal to d by 2, 4.34 by 2, or 4.4. I'm doing for both. Is equal to 2.22 nautical miles and 4.34 divided by 2 gives me 2.17 nautical miles. Radius. Good. Everybody has got the correct answer. Remember, it is easy to find out the radius or a diameter of a turn. Can you solve it for rate to turn also? Let's see if we can play with this question and then we are done for the evening, students. I think 5 minutes are left. Oh, no problem. What happens in rate to turn? Manan, that was very quick. Always mention the units also. Nandini Anukul waiting for your answer. Manan, cross check your answer. Now rate to turn is 6 degrees per second. So 360 degrees per minute. Therefore, at 25 knots, how much are you traveling in 1 minute? 250 by 60 is equal to 4.16 nautical miles is your circumference. So Manan, I think you'll have to cross-check your answer. Nandini and Nukul, where are you stuck?
So it's 1.32.
What?
Sorry. So wait.
Diameter and radius. What are you giving me? .16 nautical miles in 1 minute. Nandini, Manan, Nukul. I'm solving it with y'all. Where's the confusion? Therefore, circumference is 4.16 nautical miles. Therefore, 4.16 is equal to 22 upon 7 into D. Therefore, D is equal to 4.16 into 7 upon 22.
So 1.36. It's diameter.
Is equal to 1.32 nautical miles is the diameter. Therefore, radius is equal to diameter by 2 is equal to 1.32 by 2
0.6.
is equal to 0.66 nautical miles. So Manan, good job. Your answer is correct. Did you cross-check it, Manan, or were you confident? While cross-checking also, you should get the same answer. But Manan, I told you to use the unit. You have not used the unit. You have not changed your answer.
Sorry, sir.
Yeah, it's okay. Students, the best part about taking values in scientific calc is that whatever value you get after 2 decimals, you use the same answer and do multiply, multiply, multiply. So you get more accurate answers. If you can keep your answer and you can just multiply with your answer. Correct, Nandini. Nukul, where is your answer, Nukul?
I've given you saying verbally.
Verbally, okay.
Already.
Okay.
Yes.
Just write it in the chat box also.
Okay.
Students, it's all about logic. Okay, general navigation is all about logic. And in navigation, mostly your numericals will somewhere deal with a circle only, 360 degrees, or 1/60 rule, or sexagesimal system. That's it. Okay. Remember this much. Next week, students who are joining us for regulations and MET will be busy with that. For navigation, I'll keep only 1 or 2 lectures in the next week for our class. I'll have to check the list of topics that we had written down that we need to cover. Based upon that, I'll be covering extra topics. But I need some time to gather material and give you for calculations and practice. Everybody has the recent copies of Oxford for further reading. Nukul, Manan, Nandini, you all have it?
So
I
Yes,
don't
sir.
need to give you a small PDF version of it now, right? You are able to read it on your own, the textbook. You should have the 2014 version, okay? The one with the dark blue color cover. 2014. Okay. So read, add to the points. I think only some VOR numericals we have to solve nicely and we have to do compass errors, I guess. Not much is left. So make sure you read and you study your projections also thoroughly. Okay. And please be ready by yourself. Okay. Up to the point that we have learned. Okay, Manan, Nandini, Nukul, and other students who are watching the recording, like I think Viral is there and there. I think Muhammad Azam will be watching it. And then Twarita and Shraddha are busy with their college exams. Okay, Subhajit also will be watching it. Sankalp is done. Okay, fine. So any questions? Is it easy to understand what we have done? Rate 1 turn, rate 2 turn. We can find out the diameter and radius of a turn with a TAS. And we can also find out the correct bank angle for a particular TAS. Don't forget these points. These points will really help you in your tough times also. Okay. Plus, we have written down important points about these gyros. Couple of points I think we can still add: degrees of freedom for DGI and AH. Because turn and slip indicator, we have written 1 gimbal, 1 degree of freedom. So that, let's see if you can find that point out when you're reading it. Please do good revision. Please let me know. Make a schedule and do timely study of navigation on your own. If you don't know, if you're finding it difficult to develop a schedule, let me know. I'll help you develop a schedule. And I'll keep a personal track of your growth. Okay. And if you all are showing me some sort of passion in this, then I'll formulate special question papers for you to practice also. Digital question papers. And we can consider a mock examination scenario also. 2 hours, 100 questions like that. Okay. It will take time, but we can do it. We have that much of time before your next attempt. Okay, Manan. Okay, Nukul. Okay, Nandini. So let's wrap it up for now. Make sure the gaps between lectures and the duration between the whole navigation studies, make sure it acts in your favor and not against it. It should not be like, अरे 3 महीने पहले पढ़ा था, अब मैं भूल गया, अब मेरा energy waste हो गया. It should not be like that. I will be there to help you and teach you anytime. So you have to let me know, sir, I've forgotten these topics, what to do, and I'll tell you what to do. Either watch the recording, either go through the notes, either read the textbook, or either have a one-on-one session with me. Or maybe I'll have a special session for you guys once again to brief and cover up few important topics in a short frame of time. Okay. Very happy to see you all, and I will see you in next week. And yes, that's it, students. I'll take your leave then. Take care, enjoy, and nice to see you all again.
Thank you,
Thank you,
sir.
sir.
Thank you, sir. Bye.
Take care.